Hello family, these are the solutions to Unit 8 sampling. Yeah, I usually have stuff to say at the beginning, but I don't really have stuff to say. I'm assuming that if you're here, it's because you care, you're trying to get prep for the test. I often talk about how you should be doing this not for the points, but for the understanding. But our team is so small now, our team of AP stats kids, that really if you're watching this, it's because you've gone out of your way to get it. So good job. I'm proud of you. Focus on the ones that you need to correct and maybe don't spend a whole lot of time on the ones that you don't, because I'm going to give, I may give detailed information on some of these problems. So if you watch the whole way through, it might end up being a little bit longer. So number one is about bias. On both problems, remember there's three things that you want to do when you describe bias. So if it has a name, you want to say what the bias is. You want to say why that's a problem, and then you want to indicate whether or not that will lead to an overestimate or an underestimate, if possible. If you can figure out what the direction of the bias would be, you want to state it. So I'm going to say that one more time. If the bias has a name, you want to say this is bias because. You want to explain why that's an issue, and then you want to state whether or not it will cause an over or underestimate. So number one is a question about agreeing or disagreeing with the statement that Americans should preserve their constitutional right to keep and bear arms. So this is biased because of question wording. So the sample is biased by the wording of the survey question. Starting the statement with Americans should preserve their constitutional right is leading individuals to agree with the statement. This will result in a prediction that is higher than the actual proportion of the population that oppose gun control. Your answer doesn't need to be the same as mine. Lots of you guys gave really good responses here, but if you got marked wrong and you don't understand why, just come talk to me so that I can explain to you what about your reasoning would not earn full credit. You did not have to say, like I said, you don't have to say exactly what I said, specifically about the wording Americans should preserve their rights. That's not the only way to describe that. So many of you guys did a very good job at describing A. B, this question has a ton of issues. So number one, it's response bias. It's very, very sensitive. Up here, no, just kidding. No, I'm thinking of a different problem. So, it's response bias, number one. Number two, they're asking you, a policeman is asking you, and the principal sitting in on the interview. So this is a dumpster fire of a question. This is a dumpster fire of a survey, is what I should say. So this sample is biased because students are unlikely to admit to doing illegal things in front of just their principal. But having a policeman ask the question makes it even more unlikely for students to answer truthfully. Now here I could have just said this sample is biased because of response bias, or this sample will suffer from response bias. I'm not gonna miss any points because I didn't specifically say response bias. So I'm okay to just say the sample is biased because, and I won't get marked off for not explicitly stating that it's response bias. So I did hit the three elements. Why is it biased? Why is that an issue? And over or underestimate. I didn't read that part though. As a result of this response bias, so I added it in there. Good job, teacher, A+. This sample will predict a value lower than the actual proportion of teenagers who drink and drive. So, number one. Number two, this post-it is just going through my grading. So, how would we get a list of 1,000 customers? You can use HAT method on this if you would like to. It's just not practical. You'll get full credit if you use HAT method, but it's not really a method that anybody would use in real life. So I decided to use technology. I label my customer with a unique integer from 1 to 30,000. I'll use a website to randomly select my sample. I'll go to random.org. There is an app on the homepage that will generate random numbers. I will enter 1 as my min and 3,000 as my max. I will hit generate until I have 1,000 unique integers, which means I'll ignore repeats. The customers that match the 1,000 unique integers generated will be my sample. I'm worried that some of the things that I said in class may have led you guys to believe that when you're describing how you would select a sample or randomly assign to a treatment group, that there is a little bit of leeway in what you have to write. There is no leeway, family. You have to be as explicit as possible. If it is your AP exam, that is the one time you want to slow down and you want to think to yourself, I need to write this so that somebody that's never taken stats could do what I'm describing. So on an assignment, I can understand why some of you guys don't write as much as you could, but you're going to perform how you practice. So if you practice half-heartedly, then when you get to the exam, you don't want to just expect or think that you're going to be able to pull this explanation out of nowhere. So I know that it's cumbersome, but you guys need to get used to describing very explicitly, very painfully, how you would choose a sample or assign to a treatment. You can't leave anything out. Everything on here is important. Part B, why shouldn't we use 32.5% to estimate the proportion of the population that had issues? Well, 35% should not be used to estimate the proportion of the entire population, which is 30,000, with power door lock problems, because it only represents the cars that had door lock problems, given that the car had some sort of problem. You can use 13 out of 1,000. So to make this even better, I should have or could have written somewhere, the proportion is not 13 out of 40, it's 13 out of 1,000. Most of you guys did really good with your descriptions on this one. And then the last one, you just use this fraction that I said here. 13 out of all of the cars in the sample had an issue with power door locks. So then you would take your 13 out of 1,000, multiply it by 30,000, and get 390 cars. If any of this is not making sense to you and you need more of an explanation, we'll have time in class every day until your test, and plenty of days in between there that you can come and get help from me, and it'll be quick. So just don't hesitate to come and ask me for specific feedback if you need it. Number 3. Why would we use the median instead of the mean? Well, they're specifically looking for you to say here that the median is resistant to outliers. So median is resistant to outliers, but the mean is not. The mean is also not resistant to skew, and the distribution of income is likely skewed right. Using the mean would lead to an estimate that is higher than the typical income of these graduates. Since the median is not affected by skew and outliers, it would provide a better estimate of the typical income. So you needed to say median is resistant, income is likely skewed right and or has outliers. This will lead to an overestimate of the income. One thing that it would be really, really nice to see is if you guys included, since the median is not affected by skew and outliers, it will provide a better estimate of the income. Then the next one says, which method would you use? So you have to compare the two, which means you need to discuss method 1 and method 2. You can't just say, I would use method 2 because. You have to say, I would use method 2 because, and method 1 would have these issues. So you needed to somehow recognize that there was bias in method 1, that the bias would produce an underestimate, and that method 2 is unbiased. Family, unbiased. So I would select method 1. Just kidding. Sorry, guys. I would select method 2. Method 1 will probably result in voluntary response bias. Class members with larger incomes might be more likely to return the form than class members with smaller incomes. The mean income for such a sample would overestimate the mean income of all class members. Even though the sample size is smaller, method 2 uses random selection, so the sample will be representative of the entire class and result in an unbiased estimate of the mean yearly income. So, if you are watching the solutions for this, I want you to write this down. And I'll look for this when I go through and grade your corrections. It is extremely important that you understand that statement. Even though the sample size is smaller, method 2 randomly selects the people from the population. If you have random selection, then your sample will represent the population, which means that you will get an unbiased estimate of the mean. This includes a lot of different chapters. So even though the sample size is smaller, we know that a larger sample size is better. We're telling our grader, I know that a larger sample size is better, but method 2 uses random selection, so that's unit 8. So it will represent the population. That's all throughout our units, it seems like. The result is unbiased. That's sampling distributions. So that one statement is giving your AP grader so much information about what you know from this class and what you don't know. So even if you don't have it or you wouldn't have worded it that way, you need to write that statement down and feel very comfortable with that statement. Okay, we have the plots of land, and there was some issue with this one. So this one will be a little bit more in depth. The first thing that we need to understand is that these little squares represent all the plots of land, and that plots that look like this have larger diameters because these trees are older. And then it would make sense that in these plots, the trees are newer and there's a lot more of them, so the diameters are smaller. Now here's one thing that we don't know. We don't know what these plots actually look like. All we know is that there are some plots that have a bunch of old trees and some plots that have a bunch of young trees. And what if you have a plot that has a fair mix of trees? So it's saying because of previous logging practices, the growth patterns, plots with older trees such as 6 tend to have fewer trees with larger trunks, and plots with younger trees such as 121 tend to have tree trunks with smaller diameters. But they're not telling you anything beyond that. So they're not telling you, oh, the plots 1 to 100 are old trees and 101 to 200 are new trees. They're not saying anything like that. So, 1, we have to understand the setup. 2, we have to identify a cluster. Now, this problem is challenging because your cluster and your stratas are exactly the same. You would treat your cluster as a, you would treat your plot of land as a cluster. You would also treat your strata as a cluster. Oh my gosh, family. Sorry, let me get focused. I'm feeling a little scatterbrained. So, the plots of land can be treated as your cluster. It can also be treated as your strata. The biggest difference is if you treat the plots of land as a cluster, you have to go and measure all of the trees on the plot that is your cluster. If you treat the plots as a strata, you have to go to every single plot of land and take a handful of trees from each one. So, whenever you describe a cluster or a strata, you want to make sure that the first thing that you do is state what your cluster is or what your strata is. So, I would use plots of land as my clusters. To do that, I would have to number each plot of land with a unique integer from 1 to 200. Write those on identical slips of paper and put them in a hat. Shake to randomize. Pull slips out one at a time until I have 10 slips. How do I know that I need 10 slips? Because 5% of 200 is 10. How do I know I need 5%? They're taking a random sample of approximately 5% of the trees. And I think they say it here too. How would we take a cluster sample of 5%? So 5% of a piece of land that has 200 plots would be 10 plots. Once you have those 10 plots, you stop. You must say the trees on the plots of land that match the 10 slips pulled out will be the sample. Now, one thing that I have not done a great job about in this unit and the next one is at the end, they would prefer for us to write down what we're doing when we get our sample. So in this case, we're going to measure the diameter of all the trees on the 10 selected lots, and that is required for full credit on this one. To get an E, you would have to say, measure the diameter of all trees on the 10 selected plots. Now, a strata is a little bit more complicated mathematically, because if you're taking trees from each plot and you need 5% of the trees, well, if we don't know how many trees are in each lot, how do we know when we have 10%? And that is a little bit hard to wrap your mind around. So, mathematically, if you take 5% of the trees from each strata, that means that by the time you're done, you will have taken 5% of the overall piece of land. So, if you didn't know that, you would do your best to describe this with avoiding getting specific with the numbers. I will use plots as my strata. For each plot, number the trees with a unique integer from 1 to n. Within each plot, obtain an SRS of 5% of the trees using the hat method described in Part A. Measure the diameter of each tree in the 5% selected from each plot. If you're avoiding using a specific number, you could say measure the diameter of the trees that are the 5% that make my sample. For the study, give one advantage to a cluster. Many people got this wrong. One advantage to the cluster is that it's simpler, quicker, and easier than a stratified, but you need to say why. Why is it quicker and easier? Well, number one, you only need to go to 10 plots if you do a cluster. But also, if you do a stratified, you have to number every single tree on this piece of land. Every single tree you have to go out and number and know that it's there. So a cluster is faster and easier because, one, you only have to go to 10 plots instead of all 200, and two, if you do a strata, you have to label every tree. I almost said a swear word, a big one, so I didn't, because the idea of having to go and number every tree just blows my mind. So make sure you understand this one. What is an advantage to a stratified sample? Well, if you take trees from each plot, the likelihood that you'll get a sample that represents the population is much higher. If you think about a cluster, you may get very unlucky and end up with like 8 plots of land that have baby trees. You can't control what kind of trees are in your cluster, so you could end up with the majority of one kind of tree. So the advantage to a stratified sample is it will probably represent your population better, because cluster sampling might result in a sample where you have a bunch of young trees or a bunch of old trees. So notice here that when I describe that issue, I'm saying that cluster sampling is more likely to yield a sample that over or underestimates the actual mean diameter. It's an overestimate if you get a bunch of plots with old trees, and it's an underestimate if you get a bunch of plot with the young baby trees. And then our last one, the physical fitness program. The AP board loves to ask questions like this. So just be prepared, because it includes a lot of really good information that they want you to know. So number one, they give you the setup for a hypothesis test and then ask you to describe a type 2 error. So type 2 error means that the percent that would pass is less than 35, but we failed to reject. So a type 2 error means that we determine there is not convincing evidence that the recent report is true, and as a consequence, the City Council will not fund more physical fitness programs even though they are needed. You need to use context. You can't just say a type 2 error is when P is less than 35% and we conclude it's 35%. You need to add in the context. 35% of what, and what is your consequence? They give you a p-value and they want you to make a conclusion. So since the p-value is so large, like this is the largest p-value I've seen, since it's greater than basically any alpha commonly used in significance testing, we would fail to reject the null. There is not convincing evidence that the true proportion of adult residents in that's just supposed to say in the city, that will pass a physical fitness test is less than 35%. Then last, describe a primary flaw in the study. So here's what I mean by they love to give you this question, because they're addressing hypothesis testing with designing an experiment. They, with one problem, get to test you on more than one unit, and that's what they love. When you go into your free response problems, you will get a couple that are straight through all from one unit, like straight through all scatter plots or straight through all the standard normal curve. But what's more common is that they ask you about a hypothesis test, an error, and an issue with the design. That's a lot of different ideas in one problem, but you guys can handle it. You can totally do it. So C, the study described in Part B is flawed because the participants were not randomly selected. The Recreation Department recruited volunteers. It is reasonable to think that individuals who volunteer are more physically fit than the average adult residents in this city. This sample proportion likely overestimates the population proportion of all adult residents in the city who are able to pass the test. So notice here, when we describe this flaw, we're describing it just like we would describe bias. What is the flaw? Why is it an issue? What will the result be? The flaw is that people were not randomly selected. That's an issue because volunteers are probably significantly different than people that don't volunteer. What would that lead to? An overestimate of the people who could pass this test. So that's that on the multiple choice. Like I said before, if you guys need any additional help, if you want me to read a response, one thing that I thought that was really cool in class today was that after we took our mini exam, several of you stopped me and said, hey, I'm a little unsure, would I get full credit for this or would I not? Please feel free to come up to me and ask me to look at any of your work and give you feedback. I don't mind doing that at all. In fact, I encourage it and welcome it. So if you need any more guidance on these problems than what I have offered here, please just come see me. We can talk about it. It'll probably be pretty quick. And if it's not pretty quick, that's okay. I'll give you a snack. I'll sit with you for as long as it takes. So, okay. Okay. Love you guys.